Thank you. So hopefully everybody probably came here for different reasons. That is awesome. My goal is to help teach you how to tell computers to do things and how to do some other stuff good as well. I'm guessing a lot of you in the room are developers, have written software, have played with Arduinos or other IoTs, and if you have done any of those things, please do not volunteer to come up for the robot. My hope is to grab somebody who has never written code and is a little scared of computers. So, you know who you are. Don't be afraid. Only requirements is, you should be comfortable being in front of the audience for 5 to 10 minutes, and should be safe, should be fine. So my hope is to tell you a little bit about myself, to share some unsolicited opinions about programming, to get your opinions about programming, which should be great, and then hopefully program a robot. And that's the part of the talk that I've really not prepared. So I want to get to that as fast as possible because I think that will be really fun. So why should you listen to me talk about programming? Well, my name's Dave. I've been using computers for a little while, 30 years, and people have been paying me to use computers for the last 11 years, which is pretty great. I like to help people learn stuff, and I like you because you came to my talk. So thank you. Thank you. So what is programming? Hello World. How many people know Hello World? A lot of hands going up. Oh no, this is a really computer savvy audience. This is great. So okay, let's start the talk. Let's break the talk down. Pseudocode, what have we got so far? Introduce myself, establish the relationship. Okay, these talks usually have a quote. That's the next in the code. Let's execute that. There are a lot of great opinions on programming. Alan Turing, as many of you know, famous programmer, helped defeat World War II by building a crypto engine. Famous programmers don't often get a lot of credit. You might not realize that that's actually a photo of Benedict Cumberbatch, who played Alan Turing in The Imitation Game. Of course, this is Alan Turing. No, did I mess that up? Is that not? Right, this is Alan Turing. That's right. That's right, my mistake. Okay, so we showed a quote, made a joke. All right, deliver progression of ideas culminating in a robot. That's a big problem. Let's break that down a little bit more. Okay, assumptions. Programming's been around for a little while. There's a lot of weird language. There are a lot of terms that not everybody is familiar with. So, okay, well let's ask the audience. This is a good opportunity. Get people comfortable talking so that when somebody does volunteer to come up, they feel comfortable that everyone's taken a risk. Okay, so this is seriously audience participation time. Who knows what programming is? Anybody? Oh, I see a hand. All right, Nate says automating something. Good answer. Yes.
Translating between human intention and computer output.
Ooh, translating between human intention and computer output. That's good. That's good. What else we got? Using language to create the outcome you would like. Definitely. Absolutely. Trying to describe a problem to a computer. What else? Anybody? One more? Yes, sir. Systematic solution to a problem. Awesome. These are all great. In the event that nobody raised their hand, I took a stab at this. How did I do predicting the future? Sorta on track. I didn't do a great job. You all had better answers, so thank you for that. I didn't put my computer into presenter mode, so I don't know what the next slide is at any given moment, so this is kind of fun. Programming is for everyone. I have a lot of people that come to me and say, can I be a programmer? I don't know if I look like a programmer, if I should be a programmer. And programming is for everyone. I believe every one of you is smart enough, capable enough, determined enough to learn how to do programming. It's not that hard, but it can be a little scary when you don't know the terms and language. One of the first most famous programmers was a woman, Ada Lovelace. The robot that we're going to be playing with today was purchased from Ada Fruit, which is a store named in her honor. It's a really, really great resource for buying components to prototype with. And of course, programming can be scary, can be fun. So I'm going to give you some homework, even if you don't come up. If you want to pass for a programmer at a party, if you want to be able to read pages about programming online, these 3 skills are really important. Step 1 is learn the jargon. There are a bunch of weird words and terms, cool history that goes back to the start. One of my favorite collections of this is called the Jargon File. Essentially, it's a lot of inside jokes from the 60s, 70s, and 80s on people in universities who were playing with computers. It's really fun. You should learn how to ask a question. This is really important. Often people will go to a forum and they do the equivalent of posting their homework problems. They'll say, I got this problem in class, here's the literal text of this, will someone please solve it for me? And usually what that community does is that pushes back on that person really hard, because that happens a lot. And they go, oh, you should have Googled this. Why didn't you search the web for it? And that whole forum turns into this hate fest on that person who posted a question, who was trying to ask a question. And really, we can avoid all of that if you follow this guide. It's really, really long. You don't have to read the whole thing. And then sample the culture. I love XKCD. How many people have read XKCD? Yes, such a technical group. A lot of good programming jokes in there. And also, familiarize yourself with the editor war. You don't have to pick a side, Emacs versus Vim. You should pick Emacs. It's really not important, but if you're at a party with nerds, it's helpful for passing as a nerd. Programming, in my opinion, is really frustrating. How many people have been frustrated while programming? Yes, all right. This is true. This is not a joke, right? This is a real thing. Programming, essentially, you're going to something that has no brain, and you're trying to put your brain in that thing. You're trying to tell it what to do, and often there are going to be communication problems. So I'm going to give you some really simple steps and tools to help you deal with that. So when you're frustrated, take a walk, go to sleep, let your subconscious engage in a problem. Your thinking, forward brain is doing the things that are a force of will. Your subconscious brain, if it's interesting enough, if the problem is interesting enough, is also working on the problem. How many people have solved a problem after a good night of sleep? How many people have solved a problem staring into space? How many people have felt guilty staring into space at work? You're actually working. That still counts. I count that. I try not to bill for it when I'm doing consulting work, but it counts. And perfect is the enemy of good, right? Start from something you understand and build from there. Iterating is really important. All right, how do you solve a problem you don't know how to solve? You break it into smaller problems that you can solve, right? And you keep going, turtles all the way down, XKCD reference, very important. And you try to break the problem down. If you don't know how, ask someone who does, go back and try it again. Notice we haven't talked about code yet. We haven't shown any code. These are just life skills that I'm guessing most of you are familiar with. And finally, one of the most important things I found, working on a project for 6 months, you're frustrated, you're burned out, you're out of energy. The thing that's gonna finish that project isn't talent. It's not how smart you are. It's not, it's not how many Red Bulls you drank. It is your personal motivation. It's, am I dedicated enough to be frustrated and still do work? And that's, I think, one of the most important qualities of a good programmer, even though that can be really painful. But besides all of that, programming is awesome, right? You're taking something out of your head and you're bringing it into the world. Compared to other things, the barrier to entry is really low, right? Building a robot, you have to work with metal and plastic. It's really hard. Programming is just lines of code. It's really easy. We heard a talk from a gentleman who helped develop Gopher, which is a precursor to the internet. This is Tim Berners-Lee. He was talking about meeting Tim at a meeting, and he wasn't so sure about Tim's crazy ideas about the web. But Tim's absolutely right. When you're on a good kick, when you're in the flow, programming can be one of the best things in the world. All right, so let's recap. You listened to me talk about programming, thank you. A little bit of history, motivation, frustration. Is it time to get brave? How many people are dog people? How many people are cat people? All right. So there was a study that said that looking at pictures of cute animals helps you be more productive at work. This is a real thing because it releases tiny little bits of dopamine in your brain. So let's just take a minute and look at more pictures of cute animals. The one on the left is really, I don't know how they feel about the ducklings. It's kind of upset. I don't know if that was photoshopped or if that's real. I hope that's real. Okay, but more kitten pictures. Okay. All right, volunteers. Now this is tricky. I don't have a good methodology for picking a volunteer. So I'm hoping this will be a collaborative experiment. Yeah. All right. All right, let's play a game. Raise your hand if you recognize this. Anybody? Okay. You there, what is it?
Logo, turtle.
Logo, it is the logo turtle, yes. Did anybody play with this in school? Cool. Do not volunteer. Put your hands down, because we're gonna do that. All right, this is the part where we pick the volunteer. Would everybody stand up? If you feel so inclined to stand up, you don't have to. All right, people are standing up. This is great. You don't have to, if you're not volunteering by standing up, this is a good chance to stretch your legs, and we're gonna weed people out. Okay. All right, who has heard the joke, there are 10 types of people in the world? Those that understand binary and those that don't. Raise your hand. If you're standing, I'm sorry. Sit down. Okay, that worked better than I thought. That was great. All right. Yeah, I was gonna. That's a good one. All right, raise your hand if you've heard this joke. There are only two hard things about programming: cache invalidation, naming things, and off by one errors. No? Okay. All right, this is good. We've got our four. Would you come up, all four of you? Thank you. All right, we're going to go through one more round of elimination. I'm going to put you on the spot. I'm really sorry. So I thought about this a little bit. This is maybe a terrible idea. How do you all feel about a haiku battle? Exactly. Yeah. So a haiku is a poem that goes 5-7-5, 5 syllables, 7 syllables, 5 syllables. I like this because it's kind of like programming, because you have to describe something in a syntax on the fly. Is this a terrible idea, or what do you think? Thumbs up, thumbs down. A haiku battle. So my thought was, I'll say a haiku. I'll pass the microphone to the next person. They say a haiku about anything. And we'll keep going until people mess up syllables and have to be dropped out. Maybe, maybe not. I'm open to suggestions too if someone has a better idea. All right, we're gonna do it. Huh? We could do random. We could do Rochambeau, or rock paper scissors. Should we rock paper scissors it? All right, let's haiku battles 2 on the spot. All right, let's rock paper scissors. Okay, so 1, 2, 1, 2. My haiku? My go-to is always haikus are easy, but sometimes they don't make sense. Refrigerator. But that's cheating because I didn't write that. I have it on a shirt. Okay, so the 1s pair off, the 2s pair off. Rock, paper, scissors, best of 3. We're gonna do a tournament. All right. All right, I'll call it. So 1, 2, 3, shoot. Okay, ready? 1, 2, 3, shoot. All right, 1, 2, 3, shoot. All right, thank you. Where are we at? Thank you for coming up. Okay, we have some door prizes for participating. Do either of you have kids that just sat down? No? Did you come up real quick again? See me after the talk. Okay. Do you guys want to learn to program together? Should we do this as a team? Robot team? Okay. So I've one robot that's built and one robot that's not built. So you'll both get a robot, but one will require slightly more effort. Okay, oh, more kittens. Oh, that's cute. Okay, let's meet the volunteers. Would you introduce yourself and talk a little bit about why you want to learn to program?
Hi, I'm Callan, and I'm a sophomore in college, and I think it'd be useful to know how to program.
My name is Andrew. I work in kind of a techie startup, but more on the content side, so it's always good when you can get the perspective of a tech person.
Well, awesome. Thank you both for coming up. Can you give our volunteers a round of applause? Okay, so gather around, gentlemen. Here's our robot. I'm going to hold this up to the audience. Oh, actually, you know what? I'm going to put up a picture of the robot. So here's our robot. We've got a little chip on the top. That's the photon. It's like a little computer that's connected to the internet. We've got this green thing, which is the circuit that knows how to tell the robot to move. We've got these yellow things in the wheels on the side. Those are the motors that actually moves the robot. We've got a little battery pack in the middle. Does it kind of make sense so far? Feel free to refer to the diagram. We don't have a wooden table here, so it's a lot different. So try to ignore that. And eventually this thing should get online here. Okay, so we should make the robot do a thing, right? So far we've gone over no code. I haven't met either of you before. I didn't sneak you programming materials before the talk. Is that correct?
That's correct.
I'm beautifully ignorant.
This is horrifying. All right. Okay, audience participation again. Please pick a shape. Think carefully about what shape you want to represent. In the infinite possibility of shapes, I have made 4 available because I know how to code these shapes into the robot. So I wanted to be a little careful about what I picked. All right, so the people who want to see a line, would you raise your hands? Line? All right, we've got one for line. Rectangle or square? Who's got square? All right, we've got 4 or 5, maybe 6. Oh, 10 people for square. Circle? Oh, no. The hardest one. Okay. And triangle. Who wants triangle? Okay. That was mean. That was mean what you did. Okay. So what we're gonna do is we're gonna talk into the microphone and mumble quickly while we try to solve this problem. There'll be quiet mumbling, concerned looks. We're gonna sketch this out on paper real quick. I don't think there's a camera to show it up on the screen, but I'll hold it up to the thing. All right. So this is. Do you feel comfortable narrating what we're doing? No, not at all. Okay, that's fine. Here, would you hold that? Actually, let's do this. So we're gonna. Oh, sorry. Thank you. So what we're gonna do is these gentlemen have probably never seen this before, but we're gonna open up a code editor. We're gonna make a new app. Or actually, here we have one here called Sandbox. So this is a program. This kind of fits the Arduino pattern, where there are two places where things happen. There's a setup and a loop. Setup happens one time, and loop happens over and over and over again. So what we need to do, well, actually, let's break this down, right? So, okay, we picked a circle. So how do you think we should actually get the robot to move in a circle? It's okay if you're not sure yet. I think we want to drive the robot in a circle. That's a good question, right? So what can the robot actually do? So we've got wheels on the robot, so the robot can turn either of these wheels.
So I would say if we could spin one wheel slightly faster or slower than the other, would that turn in a circle?
Yeah, I think that would work if we kind of take our hands and do that movement. I think that makes sense. It sounds like you've played with a robot before. Okay. Or drove a lawnmower. Sure. Okay, so we want to turn one wheel faster than the other. I think that'll go in a circle. I think that's a really good idea. So what do we need first? We need to know how to talk to the motors, right? So what I'm going to do is, let's maximize this. And there's a thing in programming called libraries, where somebody else wrote a bunch of code for you and you just get to use it, which is great. The nice thing is this, right? Somebody else did a lot of the work. So this shield we're using is called the Phobot. It was written by a guy, or built by a guy named Simon Monk. So I'm gonna grab his library and I'm gonna put it in my project. And then while we're at it, we need to actually figure out how to use the Phobot. So what we're looking at right now is, this is kind of scary, this is called a header file. And what it is it's a list of all the stuff this thing can do. So what we're looking at right now is a list of functions. So we can set the motors, we can pass it control commands, and we can ask some questions of it to like stand by or turn off. Int here means number, so it returns a number, it takes a number. String means text, so we pass it like a text command. But this is like sort of human readable. Yeah, does this kind of make sense? No?
It's still pretty obtuse to me.
All right, that's okay, that's okay. This is perfect, this is what we wanted. First program. Okay, so I think what we want to do, ooh, can I get away with this? Actually, would you like to type? Can I put you at the keyboard? Sure. All right, so I'm gonna cheat, and I am going to grab a program that drives it in a line. So here's our line program. All right, and let's delete these bits because we don't need that. Okay, so there are no wrong answers here. I'm going to put you on the spot. I apologize in advance. Will you read through this and kind of describe to me what you think it means?
Tells the particle to go.
Totally, yep.
Um,
So we have a go, and we're sending some commands to the bot, right?
yeah.
Okay, so in this case, F means forward, and then we give it a speed. So we're telling it to go forward at 100. This looks kind of crazy, but what we're doing is we're telling it to not do anything for some amount of time, and then we're telling it to stop. So,
Okay.
will you click this flash button? All right, what's happening on the board?
We got an LED, blue, red, green. It's green now, so I guess it's on.
Okay.
Turned it on.
Awesome. So we took this program, the line program, sent it to the photon. It's on now. And so we have this little function called go. So what we can do is go back to this console and say, here's my device, here's that function. Will you put this on the ground and face it that way? So we cheated, right? I wrote this program ahead of time. We're using a library. But we're going to tell it to go. So what does go take? Go takes a number of steps, and then it just uses that. It waits an amount of time. So will you type a number in there, maybe something between 1 and 100, and then click call. Awesome. All right, let's call that. 56, great number. All right, so our robot is driving in a line. This is amazing. It waited exactly 2,300 milliseconds, and then it stopped, because that is... All right, so, okay. So now we want to turn one motor faster than the other motor. So let's look back at our library. How do we do this? All right, you're controlling your first robot. That was, we cheated, but that's okay. So we have these commands for set motor. So I'm going to grab these. Or actually, we don't need these. We have these commands that say, okay, S is stop, F is forward, B is backward, left. So actually, to turn in a circle, we can just use this built-in thing, right? So let's go back to our sandbox. So we can turn left and right. All right, we went in a line by going forward. We turned both motors on, went straight. So could we turn in a circle just by going left or right? Maybe? Turns one motor. Yeah. Should we do that? Do you want to change it to spin it in a circle? Instead of F-100, could you make it L-100? Yes. Do you want to click the lightning bolt? So what you did here is there's a chunk of text getting past that function, and that other bit of code knows how to chop up that text and interpret it. And so you change the command from forward to left. Are things blinking again? Waiting for it to get back online. Almost. Almost. Here we go. All right, it's back online. Do you want to tell it to go? Yay! Do you want to do it again for those in the back? Yay! Yay! I'm happy about that. Good job. I'm really glad you thought of the easy way to draw a circle. The hard way to draw a circle involves like sine and cosine, and it's really terrible. So with a robot, it's a lot better. All right, so let's do this again. Pick a shape. What's Andrew's shape? Anybody? Hexagon? N-sided gon? Ooh, that's mean. All right. No, we can do a hexagon. We have time. What time are we at? We're about 20 minutes in. Okay, so how would we do a hexagon? We know how to turn. We know how to go forward and backward. What's a hexagon? It's a shape with some number of sides, right? Straight turn, straight turn. Okay. So let's make a new program. Would you like to? Do you want to drive? So let's give it a name. Let's call it Andrew's Awesome. Hexagon. Cool. All right. And let's click Enter to save it. Perfect. And then click on this little bookmark here for libraries. And then grab that Phobot library again. And then include in project. And let's put that in Hexagon. Confirm. Cool. Okay, so now we have a new program, blank program with Phobot. Let's create our Phobot object again. In the last program, I think you just said a Phobot, capital P-H-O-B-O-T, space bot. So go down to line 3 and add a couple lines in there. So capital P, H-O, B-O-T, sorry, capital B. This is the fun of programming. Space bot, and then a semicolon. Semicolon. Okay, so fun programming thing. Computers are really bad at reading text. It's really hard. And so sometimes we try to make it easier for them. So a semicolon tells the computer, I'm done with the command. These little curly braces kind of give it a scope to work inside of. If you go back to these carrots over here, yep, the code, and scroll up a little bit in this window. Oh, sorry. So mouse over and then scroll up. Yep. And let's go back to Sandbox. Okay, so here's kind of this general control structure that we've had. So do you want to copy everything between 6 and 20? So just like, yeah, Control C, and then let's hit the code thing again. These little, oh, sorry, command, my bad. Code, and then scroll down again, and go back to Hexagon. And then let's select 6 through 12 and then paste on top of that. All right, copy paste. Important programmer skill. This is fantastic. How do you feel? Do you feel good? All right, good work. Okay, so we're making a hexagon, so that's 6 forwards, 6 turns. Okay, so here we have the basic command of tell it to do something, wait some amount of time. So let's break that out. Let's unroll our loop, as they say, and just put the commands in order. So how about let's tell the bot to go forward 100. And let's get rid of steps here. So delete steps up to that multiply line. And delete that little red character too. Perfect. Yep. And let's change that 50 to say 500. We're going to make this simple. So what that tells it to do is go forward at a speed of 100 and wait half a second, wait 500 milliseconds. So let's copy lines 17 and 18. So copy that, and then paste that twice. So go just right on top of it. So hit Control V, Control V. Cool, and let's drop a new line between the, sorry, right there. You're doing really well, by the way. Right. Here, I'm gonna do the wrong thing, and I am going to grab the keyboard from you. I apologize. Okay. All right. So now we have two forward commands, but if we're turning in a hexagon, we probably want one of those to be a turn. So would you change line 20 to either a turn to the left or the right? Perfect. And then I did the math ahead of time. Let's see. So I think turning 90 degrees is about 150 milliseconds. This isn't a very smart robot. It doesn't know how far it's gone. It only knows time because the parts are really cheap. So if 90 degrees is 150, what's the angle in a hexagon? Who did high school math most recently?
Is it 135?
135?
I have no idea.
Sure, let's try it. It's wider than 90 degrees. Okay, so the delay should be shorter.
120?
How about 100? Let's do 100.
Okay.
That'll be 2/3 of 90. So it'll turn 60 degrees at a time. That's not right.
If our calculation isn't right, it's not going to end where it started. Is that?
Yeah.
Yeah.
So let's test this. Let's see what the angle is. So do you want to click the lightning bolt at the top? All right, so it's going to turn purple again. This is live debugging. Does anyone spot any bugs from the audience? No bugs yet? All right, so let's go back to the console, and then let's call our function again. And right now we're not using the variable. That's okay. That can be anything. Let's leave it, but we'll just ignore it. So what should the robot do? It went forward and it turned. Okay, so can you take your program and do that 6 times? Yes. All right, so the first thing Andrew's probably going to do is copy and paste that 6 times. How many of us have done that? Yes. That is okay. All right, let's try that. All right, the code is going. The device is resetting to run the new code. People are getting up excitedly. All right, here we go. It's on. All right, let's call it. How many turns? 1, 2, 3, 4, 5, 6, 7. Okay. We did like 3/4 of a circle. That's pretty good. That's pretty good. Yes. Okay, so we're gonna do a thing to help code clarity. We got something that sort of worked, right? Now we can iterate. So let's look at the code again. What would make this easier? What would make your life easier right now?
If one of these wise people in the audience could tell me what to do.
Oh, that's,
We're getting some good interaction here.
no, this is great. This is great. Stack Overflow. Just remember that ask question slide. All right, what should Andrew do to his code? Make a loop. All right. So a loop is a way to tell it to do something over and over and over again. The nice thing about that is you get to see this little chunk of code that's concise, and you can...
Yeah, this is a lot to look at.
Yeah, totally. So I'm going to Control Z and come back to where we were before. And then I'm going to write an example of what a loop looks like, and then have you do it for me. So these slashes are comments. So the kind of typical loop structure is live coding. All right, so Stu, will you do me a favor? What does that mean, what I just wrote?
What it means is that you're going to do a thing. If you look at the code, it says do a thing. You're going to do a thing some number of times. If some number of times was 10, you're going to do a thing, 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 do a thing? Or am I off by one?
I wasn't counting. Thank you. Oh, that's a good question. Programmers used to not have a lot of disk space and didn't talk to normal people a lot, so they shortened everything. INT is short for integer, which is math speak for a round number, a whole number. It could have just said number, it could have just been the letter I, but C programmers in the 70s wanted to make things hard for everyone. So syntax matters. Unfortunately, with programming, it's not horseshoes and hand grenades. If there's a bracket in the wrong place or semicolon in the wrong place, it will yell at you, but that is okay. That is part of it. You could totally do that. You'll have to take it out of comments, but yeah, do you want to give it a shot? You guys are doing awesome, by the way. I appreciate you participating in this insane experiment for which I am not fully prepared. He's deleting the comments. This is great. This is good. All right, we're copying and pasting. Where is he going to paste? Where is he going to paste it? It's inside. It's inside the loop. All right. We did it. Okay. So this is a hexagon. What should some number be? Do we think? That's right. That's a good point. There's this terrible thing that happens during programming where you often start with 0. So what you do is you start at 0, and then this tells it to count up to but not over that number. So I will be 0, 1, 2, 3, 4, 5. So it'll actually stop at 5. But that's okay. You can still set some number to the number of steps you want, and you'll still hit it so long as your conditional is correct.
So is it this purple, or is it the I?
So we actually, on line 20, right above it, we're going to declare a new integer. So let's go to line 20. We're going to say int some number. Look at him picking up the syntax. He's a natural. Oh, I'm going to be really precise. You need an underscore between the E and N. Yes. And then for the I, you notice we have this like equal sign and then the number and the semicolon. So let's do that same thing for some number. So if you go to the end of the line, yep, do equals, yes. And then what did we say? 6? Should we do 6? Let's do 6. Yes, and then a semicolon. Okay, so this is the same as your program before, but the forward and the turn are in one thing. And we noticed that it didn't quite turn all the way before, right? So we want it to take a little bit more time when it turns. So can we make the left turn take a little longer? So it's this part right here. Ooh, we could also make the turn faster. That would work too. So the 100 can be a number between 0 and 255. So yeah, let's do it. Make it 150. Okay, let's go. You want to lightning bolt it? Yes. Let's just take a moment. How do you feel right now?
It's still a little confusing, but we got Callan here and we're making it work.
How angry are you with me right now?
I'm not angry. This is good.
All right. Thank you.
I'm pretty sure they do this in like 5th grade nowadays, so it's pretty remedial, I think.
It's not that remedial. You are sending magic signals over the internet to control a robot in the room. Let's go back to our console and trigger that go. All right, here we go. Using the loop. Okay. So the robot's, it's got a little too much muscle. It's moving a little too fast. So let's slow it down. So let's do that by, we have this stop command here at the end. Let's put a stop between the forward and the turn so that it goes forward, stops, turns, goes forward. I think that'll help. So we're getting a little better each time. Cool. Should we try that?
How long is the stop?
The stop in this case will only last as long as it takes for the robot to do it, and then it'll do the turn. You're exactly right. We didn't put a delay in there, so it might not be long enough. All right, we're reconnecting. Compiling. Okay, should we give it a shot? All right, here we go. Ooh. All right, what should we do? We're still doing the half arc. Any suggestions from the audience? What's next? Increase the delay after the turn, double the loop. 6 to 12. We can increase the number of sides. We could redefine the problem, which is great. That is, that's okay, right? We want to make something that works, right, and get back to the solution. All right, what do you think? How would you approach this?
Who said something about slowing it down more?
This guy back here.
Yeah.
Slow it down some more?
Yeah.
All right, so maybe let's slow down the turn and make it take longer. Oh, is it lunchtime, by the way? Are we done? 5 minutes, okay. You guys are awesome. I can't believe, did we actually get through this? Did this work? No, yeah, that's right. Yep, so that's the speed, and then that delay is how long we're gonna let it go. Cool. Yeah, it's twice as much as we were before. So, I mean, this might seem remedial, but starting at that point where you have something that works, tweaking it, starting to learn the syntax, copying and pasting from examples, I think that's how a lot of us learned. That's how I learned. All right, let's do it. Hey, that counts. That counts. All right. So let's, okay. Congratulations. You guys did it. Thank you. Thank you. Hang out, wait, I'm gonna give you stuff. If you had a robot, would you use it?
Yes.
All right, that's a robot. And then, Callan, do you want to just have that one? It's yours. Here's a battery pack if you need a battery pack. Oh, you might take one of those. This is for Colin. That goes on that. And then, yeah, there you go. And then, who only got a stick? You want it? Here. You can have the R's for Robots coloring book from Adafruit. Really great store. If anybody wants a sticker or wants to chat or needs an extra ultrasonic ping sensor, let me know. I'll be out there. Thank you, everybody, for your help and participation. Thank you, guys. I really appreciate it. Okay.